Okay, guys, in this exercise, I just want to discuss a little bit the relationship between curves and surfaces and how we can control that relationship with inputting high-quality curves to output a certain kind of surface that allows us to make a clean drawing. This is a reference file that I can give you that is in support of this exercise. We won't model all of this directly, but I'm going to refer back to this as we go. Here you can kind of see one relationship between curves and surfaces, which is that this curve, you can see how it's got a kind of uneven distribution of control points, and because of that we have an uneven distribution of isocurves. Now this may or may not matter to you, but if we're trying to produce drawings of things like wireframe views like this, what we can do is, instead of sectioning this after the fact, we can actually control our surfaces in the way we draw in Rhino, such that we can extract this sort of wireframe directly. So that is a benefit in two reasons. One is that the model itself is very clean. It's a high quality model. It can be used for easier fabrication. It can be used for better drawings. The other is that, of course, the representational output is directly related to the model itself. We don't have to add work in order to produce the kind of representation. Okay. So I'm going to start with a new file, ignore that, and here it has a series of layers that I've already got set up. You should go ahead and organize yourself along a similar set of layers. Here I have construction, profiles, surface, and points, which we probably won't use yet in this exercise. Okay, so once that's set up, I'm going to go to my top view, and in the construction layer, I'm going to draw a construction line out to an arbitrary length, and another one up to kind of an arbitrary, let's say, width. So this is going to set the kind of width of the boat in the back. Then I'll go over to my profile layer and grab a control point curve, which is up here, and click to that line there. And I'm going to hold Shift to set an axis, and I'm going to click once here. I'm going to hold Shift again, click again, and then I'm going to just go ahead and snap to this construction line. And if you're not clicking, or if your snap isn't snapping to the construction line like this, make sure that down below you've got OSnap on, of course, and the near selection, the near object snap selected. Very, very useful in this case especially. And what I'll do is I'll kind of draw that, and I'll experiment a little bit with the form just by seeing what my results are. I think this might be a little too pointy, so I'm going to bring that back and maybe put it around there to make a nice tangential transition from really kind of gradual curvature and increasing that curvature to what will become the front, if you will, or the kind of the front end of the boat. Okay. Then I'm going to head over into the my view, and I'm going to select everything I just drew, and using the gumball I'm going to just kind of drag that up so that I can see it away from this kind of red axis line in the front view. All right. And then I'm going to select it in the top view, which in Rhino 6 will automatically pull up the control points. If you're in Rhino 5, you'll need to turn on the control points using the Object Control Point tool. Okay. And then I'm going to just select that front control point, and in the front view, drag that up a bit to give it some height. I can maximize that to have a better look. All right. And I can also, if I want, I could kind of modify that a little bit, dragging that all along on the x-axis. I'll leave it up to you to experiment a little bit, but try to keep it really simple. Try to keep it really transitional and tangential, something that's very gradually transitioning up and over like this. And once you're comfortable with that, head back into your construction layer. In the top view, or whatever view, I'm going to select this endpoint here. And then in my front view, I'm going to drag down and hold Shift, and I'm going to just put another construction line that's going to set the height, or let's say the height or the depth of the canoe shape. All right, so I'm just going to pop that in around there somewhere. We can adjust this a little bit later if we don't like it, but for now, that's where I'm at. I guess I'll also draw another construction line now from the end of that point over to an arbitrary distance, similar to the first one, and activate my profile layer. I'm going to start up a control point curve, at that point. And I'm going to use, now instead of 4 control points like we did up here, I'm going to use 5. And here's how I'm going to do it. So let me activate this here. I'm going to go along, snap somewhere along that axis there. I'm going to snap one more time, maybe around there, along that axis. I'm going to click on my first construction line up at the top here to set my 4th, and then my 5th will of course be the end point. That's going to give me a little bit more control over this front end here, which means that 5th control point I can use to bow this out a little bit more if I think that's more appropriate, to cut the water or just formally. I can also adjust this a little bit more if I'd like. So that's the shape that I've ended up with here. You can go ahead and play around with this and see if you can come up with something similar. Okay, let's go back into our 3D view. And we've got most of our construction set up here, at least in this case. So we can take this and this first one that we drew and just mirror that around from the first point. And now we've basically kind of drawn out the basic form of the boat. Cool. Now we're gonna take a look at the curves and see how many, just to kind of get a sense for it. We know how we drew these. We have just a few control points, so they're pretty simple. Let's go to the surface layer and loft between those two. And I'm just going to go ahead and select the keel first and then the outer profile. Okay, it looks like now I've got misalignment. Let me see how I can fix that. Yeah, let's check the direction of the curves. Okay, it looks like that's in the proper direction, and so is that. Okay, that should be okay. We should be all right. Maybe let's just rerun the command, so we'll go to loft. Okay, let's try this a different way. Let's select these first, and then, okay. So for whatever reason, in this case, I had to select the curves first in order to do the loft. Just raise your hand if you're having that issue. Many of you probably won't, but for whatever reason, I did. All right, let's go ahead and click OK. The style should be at normal. And here we are. Okay, so the surface looks pretty clean. Not a problem in terms of it being a surface. But again, let's go back to this as a reference. We're looking for more resolution. Now again, you might be saying, well, okay, let's just cut sections in it. You know, we'll draw those lines. But what if you had to draw these? Or what if you needed lines that were not exactly, you know, in an orthogonal cut? What if we wanted lines that were really described along the surface curvature in order to describe it? That's a little bit harder to do. And what I'm saying is what we can do here actually is just redefine how we draw these curves first in order to get an output surface that has more resolution. Let's walk through that. So I'm going to make a copy of all this so that I can keep a history of our process. And then I'll delete the surface that we just modeled. I guess I'll also turn off the construction line layer so that we can kind of see what we're working with here a little bit more clearly. Okay. The first thing I'll do is I'll take this curve and I'll rebuild it. So type in rebuild after you've selected the outer profile. By default, we've got a point count of 4 because that's how many control points we've used. And I'll click in 25 and hit OK. You can see now that that's added quite a bit of control points along the length of that curve that I could use either to edit that thing or in this case, draw a different kind of surface. So let's rerun the loft command between those two. And now what you're seeing is the result, the two different results here. One curve that has more control points than the other, affecting the amount of isocurves that are drawn along that surface. Now this is a step in the right direction, but you can see now that we're still creating this weird diagonal kind of pattern. And that's because this line up at the top here, sorry, and the keel are not divided the same number of times. So we're still getting this kind of uneven distribution. So let's go ahead and copy this. And delete that surface. And now we can rebuild this bottom line, the bottom profile, the same number of times, so 25. Right, so now I've got two lines that are subdivided similarly. I can loft that again. And what you should be seeing now is a more evenly distributed surface with ISO curves. That is a good start to our wireframe. One of the things, though, what we have now, because we're using the loft command and we're not setting a manual section curve here to do a sweep, which we'll look at in a future exercise, is that we have a clean distribution, meaning that it's these are more or less parallel, but we don't have an even distribution in two axes, in the U and V direction. We have a lot in this direction and very few, only two in that direction, in the long direction. So let's walk through another way of doing this, and instead of copying what we just did, I'll copy the original, okay, the first one that we did, and I'll just pull that over and then delete that. Now what I want to do is just rebuild these less times. So let's rebuild these 6 times. All right. Just a couple more points than what I had before. Let's go ahead and run the loft command, which will give us a surface like this. And now having that selected, I'm going to go over to Properties. And down here I can change the isocurve density. And let me just kind of click through that to increase it. And a layer of 2, a setting of 3 is going to now give us a little bit more of an even breakdown, and 4 is going to continue that process. So this is not a bad way of working either. Sometimes if you can only get so far with the 2 profile curves, especially if you're using loft, because that command requires parallel edges. So if we wanted to add more subdivisions in the other direction, one method for that is to simply increase the isocurve density. So let's make a copy of this. Bring that over. Let's mirror that surface that we just drew from the front point. And then I'm just going to take those surfaces only, copy those over, keeping a history of the entire process, leaving the profiles behind. Now we've been talking a little bit about how to, extracting these isocurves, right? So if I select these, I can tell that there's nothing here. It's just a surface representation in Rhino. But that is a wireframe that we can gather. So let's go ahead and join this into one poly surface. Okay. And I'm going to make a new layer for, I'm going to call this line work. And I guess I'll make it white again. And selecting that poly surface, I'm going to type in extract up at the top, and that's going to drop down all of the extract commands in Rhino. And I'm going to go all the way to the bottom here and go to extract wireframe. That worked, and it's going to put it on the layer we just had selected, which is the line work layer. I'm going to hold the Alt key and drag out that gumball axis and just kind of move that over, making a copy. And there's our line work. So we were able to extract that directly from the surface itself, which is, I think, much faster and much more accurate than having to cut sections manually, at least in terms of surface representation. Now, let's walk through a really quick kind of make 2D trick, and you may already be aware of this, but to start, I'll just kind of show the first version of this, of course, is to do a make 2D of the wireframe, and I'll just kind of select a view like that. You can kind of follow along and select a similar view. Type in make 2D, let it run, have a look. And of course, no surprises here, it's going to give us this kind of X-ray view, this wireframe view. Let's now name this view so that I can keep it. So I'm just going to go to the named views. Oh, it's already open somewhere. I guess that's, where is it? Here, there it is. So I'm going to save this view as, I guess, perspective 1. So I can go back to it in just a second. I'm going to select these surfaces and copy those over to there. And then go back to my perspective view. So I'm going to set that view as perspective 1. And this is my same view now. Now what I'm going to do, well, I'll do that in just a second. Now what I'm going to do is select both the surfaces and the extracted wireframe together. Set that view and rerun the make 2D on both of those things selected together. And let's take a look at what that gives us. Yeah. So it's very common because the lines are being selected over the top of a surface, that certain things like this could occur, where Make2D is going to get a little bit confused between what it wants to show you and what you want to see. That's okay. We can manually edit this, by just connecting the dots. And we can come up with a better way of extending that. Maybe we can just type in the extend command and bring that up. A little bit of post-processing, but really the difference here is from outputting an X-ray, which is kind of an overlay potentially of line work, versus outputting line work that's not appearing like an X-ray, and it actually looks more like the surfaces have materiality. Okay, and that's just a little Make2D trick that you may or may not be aware of, that you can extract line work, put it over your surfaces, and Make2D the whole thing together in order to produce drawings like this. And here you can really read the curvature very clearly, and you can also read that it's made of these, in this case, very thin surfaces. Okay, so that's just a little introduction, kind of a lightweight introduction into the relationship between curves, how you draw them, and what the output surfaces are, and why it's useful to work in such a way where you're conscious of that. I'm just going to go, in the end of this here, I'm just going to go and kind of explain a little bit about, delete that. This is the file that you have as a reference, and I'm going to walk through this again as a conclusion. Here I drew the curve differently. I referenced an image and I kind of traced it out, being more careful. But the result of that, again, is something that actually has a bit of sloppiness to it. And by sloppiness, I mean not only is the output surface unevenly distributed and a little bit overly complex, but let's have a look at its curvature graph. So I'm going to type in curve, and it's going to pull up the curvature graph command. You can adjust the scale at which you're seeing the curvature graph. This is telling us the nature of this curvature. Here I can see that it's all over the place over here, and it's really kind of a mess up here. So let's do a little bit of work to this, and let me add that object because that's the same. So I'm going to take this one and copy it out and show a couple of commands that may be useful to you as you're kind of trying to build out a clean framework for surface building. In this case, what I'm going to do is first start with the fairing command. So type in fair, F-A-I-R, and let that, well actually the first thing I should have done is rebuild it. So let me rebuild this to kind of, first of all, drop the number of control points I have, and also clean them up kind of in a way, space them out a little bit more evenly. So I'm just going to go with 20 on that. That's going to affect its curvature graph already, cleaning it up slightly. The fair command will also, it's not going to change the curvature much, but it is going to at least change the nature of that curvature. And if I hold the shift bar down, I can see that I can repeat that command and continually, gradually improve upon the quality of that curve. Another command that I think is useful is smooth. So for that, I'm going to use the bottom keel here, and I'm going to copy that over and just kind of snap it to the front here. The curvature graph of this will be quite severe and really bad. As you can see, I'm going to drop the scale of that so I can get a better look. And here's an example of when we go from positive to negative curvature and then back again. And that's not ideal, especially for fabrication. When you're drawing a curve out like this, you don't typically want it to kind of pop back up and then down again. Anyway, that's a conversation again when we get into some more advanced topics in terms of building things and extracting the amount of information necessary in order to construct things from real materials. But in this case, instead of running the fair right away, let me first rebuild, and I'll run the smooth command to see if we can kind of at least get this lump out of here. So let's run smooth. We can change the number of steps, I guess, to 2 just to speed it up a little bit. And I'll repeat that a couple times, at least to get our curvature on the right side of our original line. And this one, you should note, will change the curvature of the original input curve. It's going to change its geometry. And that's something you're going to have to be aware of. But that's going to happen no matter what you do. If you were to drag the control points around in order to manipulate that to fix it, that would also be the case. So you got to go back and forth. It's a bit of a trial and error to get what you want out of this. In this case, because I'm not referencing anything directly, I'm okay. Our curvature graph is pretty clean, and I can kind of fair that maybe a couple times just to kind of even it out, especially in this area. And I'm going to get a little bit of that curvature back over here, but I'm going to end up with a slightly more pointy front end. But that is the result of this process. You can already see a couple of commands here that might be useful depending on how you start. Over here, how we started was to just draw the lines cleanly. We drew them with control point curves with very few of them, 4 points in this case and 5 points in the other. And then we went through the process of rebuilding them and increasing the density of the surface. That was the result. Here it's slightly different. We went through a process of kind of tracing out an image, which is okay, but we then have to go through and sort of clean up and fix the result of that in order to produce surfaces that are back to what we're looking for. Okay? So hopefully this is a kind of a good and clear introduction to again, the relationship between curves and surfaces, why you would want to be conscious of this. In this case, I've only introduced an output that's a drawing, but in the future, in the next set of exercises that are linked to this, we'll talk about ways of actually modeling the paneling of these surfaces that you may be able to take to a fabrication process. Okay, so if you're feeling comfortable with this so far, between your own work and the reference file, feel free to head on off to file number 2.